seesaw. We'll see.
Really stressed out your grass.
Still let them have it.
Getting closer and closer, right?
Yeah.
Good.
I feel a
I mean,
little
you're like,
suffocated.
you almost finished. That's why.
Right. Why does my
Your whole life is back.
It's about a plummet.
Alright, so, let me tell you, so you guys are doing really good, this is one of my favorite classes I teach, 120 for many years, like, I teach to business students, I know how hard to teach, math, especially in first year classes, especially for business majors, so hard. They're not taking things serious, they don't do work. Even if I give the same questions to them, really, they don't really show the progress. But you guys are, we discuss questions in the class, and I change the question and give you challenging question, and most of you show the progress. You can see from, you can even reflect yourself. Yeah, the first week of the class and now you learn a lot of things, right? I can write down the list of topics that we've been discussed. I can take my time, but you can try the same when you study. That's how you study. When you can write down, okay, what I learned this class before you start. Not only this class, you guys do. Okay. So any class, for an example, chemistry, when you study chemistry, think about what are the topics you learn, and find out how can I improve this section or this concept more. Read textbooks. I can see one of the what it's called, one of the weakness of you. Most of the students I see, you don't take time to read textbook. Read the textbook, okay? Because when you graduate and you go and do some, somewhere you get employment and you work, and if someone asks, okay, what is the best textbooks for Precalculus or whatever course you are taking, you should be able to name the textbook and the person who wrote and so on. So that because you can't find my notes after 3-4 years, right? But you can have reference to the textbook. Okay, you have to have some connection with my notes and the textbook. So how to develop that for not only math, for any other courses. Even though I give a lot of resources, make sure you use textbook. Textbooks is something you have to, time to time you can look back and remind what you learned. Okay. So what I'm going to do, I take like 5 minutes to write down the list of topics, like 10 topics that we discuss in this class. Okay. So if you see my practice problem, I create questions so that we can cover every topics that we learn in class. Okay. So these are math 120 free calc. We first learn domain and range. Remember. So there's no such a question in this. Maybe I'll include one, giving you some function and ask you what is the domain and range. Okay. So like this one. Remember you had similar question in your test one. I remember. So I can give you something like this, and this is 2. This is 5. Remember. This is 3. Can anybody quickly tell me if you have something like this? What is the domain? 2 to 5. You look at the x-axis, and those are the inputs you can put to get the function. There's no graph over here, so you don't write anything. The range?
3 to 6.
How about it? It goes down up to 2, let's say. It's going somewhere here as well, right? So it should be 2 to 6. I stick with that, sometimes I give the same question, some students say the same answer you gave me, like 3 to 6, but no. It can go below that, okay? Something like that, keep in mind, okay? Domain and range, what else? One of the themes we discuss in the entire course is functions. You see linear function, quadratic function, polynomial, cubic, trigonometric function, we use synthetic division, all are functions. Okay, sine, cosine, tan, all are functions. Because when you go to Calc 1, you talk about like dynamics, like how the things change. Environment change, climate, all those things change. You can, for an example, if you do chemistry, you know certain chemicals you put and the things are changing, color change and all those. You can model using function because functions are kind of a way to discuss the changes. Okay, so functions. So I'll write all the different type of function you learn. Linear function, quadratic functions, quadratic function you learn about open up, open down, talk about vertex, and so many other things. Okay.
We get a front and back, right? Like,
Yes.
oh, okay.
Formula sheet. Yes. So nice. I know. Because you have so many things.
Yay!
You can like formulas. Quadratic, and we talk about polynomial. In this polynomial, we talk about even like many degrees, x cubed, x to the power 4, and so on. Okay, polynomials. Under that, we talk about polynomial division. We learn about synthetic division and log division. Most of you don't like log division, but you prefer synthetic. Okay, but log division is kind of a general division, polynomial division. And one of the things I missed here, and put a star and write rational function. And also another type of function, we talk about inverse function. Okay, how to get back the function and how to come back. Inverse function. Okay. What else you learn? Synthetic division. You can check. Yeah. So, synthetic division, log division are type of things we use to get the idea of factor and remainder theorem. Factor and remainder theorem. And also I can write rational zero theorem. Okay. All are connected. Rational zero theorem. And then we come to trig. Okay? And I read the last test I asked what are the things you learn. Most students say you learn a different approach in trig. You start maybe mid circle, and some of you mentioned that you never draw sine cosine graphs, and you learn in this class how to draw sine cosine tan. Okay? So trig functions. We talk about drawing sine, cosine, tan. We talk about sum formula, difference formula, double angle formula, especially the unit circle values. Yeah.
You
So you get it?
We get it, I just don't like the.
Okay. Bring that unit circle that I posted, the general one, not just the special cases, with the radians and degrees and all those things. And you can write tan value next to it if you want. Okay? And sine, cosine, tan, and you take the reciprocals and you get cosecant, secant, cotangent, and also we learn trig inverse functions. Trig inverse function we learn. Graph trig functions. What else I can say? How the sign change, all students take care.
Yeah.
Okay. Sum and difference. double angle formula. That's where we stop actually, okay? Double angle and triangle here, formulas, okay? Double angle formulas, graph those things. Under graph you understand amplitude, period, phase shift. Well, that's I think how these are the topics we mainly discuss, okay? Kind of a big picture. You can see when you start the question, start from the beginning, I give you a question from linear function, straight line, parallel, perpendicular lines. Question number 2, I forgot, composition function, okay? So quadratic, rational, can I composition, but how to combine two functions? Composition of functions. Actually, kind of overall like 15 major topics. Composition functions, transformation of function. Anybody remember?
Oh, it's like +2 minus.
Right, you get,
Right.
yeah, take up, take down, take left, right, and so on. Okay, yeah, transformation of functions. Yeah. Good. Let's stop there. Okay. Right, we'll start from question number 1. Okay. Ask questions. If you feel like anything not clear, let me know. Otherwise, I think you all understand the concept. You don't ask any questions. Right? Okay, so I'll start. Question number 1. I'm not going to use projector because if I use that, I can't use the board. I need to use the entire board. You can check your questions, okay? For some question I can write down. The first one, good, okay? First question. Find the equation of the line containing the given point 1, 6 and 3, 7. I can give you 2 points and ask you the straight line that can go through those 2 points. Okay? So because any straight line, you know, if you tell me any 2 points, how many straight line I can draw through these 2 points? Only 1. If I give you just 1 point, you may draw it like this, then I can't write an equation. Yeah? So you should at least need 2 points to draw a straight line. Okay? So if you have 2 points given, first get the slope of the line. You remember how to get the formula?
Change one or change next.
Right, so rise over run. Okay? Y difference gives you how much you rise, X difference gives you how much the run. Okay? You don't need to draw anything. I normally, when I teach, I draw it because I need to give you some kind of visual how you know. But first get the slope. 7 minus 6, 3 minus 1. So it's just half. Okay? Getting slope is, I think, most of you can do that. Okay? And then I know half mean is like an incline this direction. If you want, you can mark it like 1, 6 here, 3, 7 here. Okay. This is the run, this is the rise, and that's the slope. This over this, okay? Rise over run. And how do you write the equation? This is again, most of you seen this in high school, I'm sure. This is the formula for equation of a line, equation of the line, when you know the slope and a 1 point. I know 2 points actually. Those 2 points give me the slope, and I use it here as half. And now the question is, what is the point I'm going to use for x1, y1? I already choose x1, y1 as 1, 6. You can use that. Surprisingly, if you use 3, 7, you would get the same answer. It doesn't matter what you choose. but you know, since you already marked it x1, y1, let me use that. Okay, this is x, this is y. I know, you know, I sometimes when I grade, I know sometimes a student switch that mistakenly. Don't do that. This is x, this is y. And subtract x from x, y coordinate from y. And I get half x, half time is like x over 2, right? And this is half and add 6. Why you add 6? Because it's minus 3. And this is what? X over 2. 6 you can write 12 over 2. Agree? The reason is now I have same denominator. So what is the answer? Plus 11 over. Because you have to simplify this in minus. Okay. Good. Question, yes. Yeah.
The onus or also in the slope standard form.
Yeah, that's good. Yeah, you can write slope intercept form. That's fine.
But this fine is all we use the other one.
The general form you mean?
Yeah, like
The general form is just bring everything to the left side. But if you write it point slope, slope intercept, that's fine. Okay? Because you know, it's a new name, but this is enough for the test. Okay? All those forms I teach you because in math lab sometimes you need point slope, sometimes general form, so that you have to know these names, but you know how to get it. Good. Good. Okay, so let's say you get the answer. How do you really check you got the answer right? You can check it like this. If you plug 1 here, what you will get for y? If you plug 1, it's 12 over 2, 6. You see? You get the answer. That means because this is the equation that goes through these 2 points. So these 2 points should satisfy the equation. Satisfy by what I mean is if you plug x value, you should get the same y value in that coordinate. For example, if you put 3 here, what you would get? 3 plus 11, 14. 14 over 2, 7. So you can plug at the end, and if you make an algebra mistake, you can detect that. Okay? You can figure out, oh, I made a mistake, and you have to check the algebra. Right. And the other 2 questions, check what happened when you have, how do you do parallel lines and perpendicular lines. Find the equation of the line parallel to the line 3x plus y equal minus 5. Okay. Let me write it here. So this is the line. So you have a straight line given as 3x plus y equal minus 5. And you need to find the straight line that is parallel to this, and it goes through a point given here. This is the point 2, comma. Those 2 are parallel. Sometimes you mark it parallel as in these 2 type of arrows. It says they are parallel. Okay. If you have parallel lines, they have same slope. They incline in the same direction, same slope. Okay. So what is the slope of this? It's not directly give you the slope. You have to take all the other variables to the right side, and now you can tell me the slope. What is that? Negative 3. And since both are parallel each other, I know the slope of this line is negative 3. Now what? You know the slope and you know a point. Previously, you can't find the equation of the straight line if I don't use that information like it's parallel to that. Since it's parallel to the other straight line, I can get the slope as same as the previous. So I know the slope now. Now how do you do? You use the same thing. Because now you know a point and a slope. I'm going to use the same formula. Okay? Y minus y. What is the y coordinate here? 3 minus 3, x minus 2. I'll give you a little time. About that close, you understand? Good? Okay. So we discussed this of way like maybe third week maybe during our first few weeks, okay? Right, so then you have to simplify y equal negative 3x plus 6, and you bring this 3 to other side, it's become y equal negative 3x plus 9. Okay, right. Must multiply negative 3 with x, negative 3 with negative 2, positive 6. 3 brings to other side, give me plus 3. Okay, so if you want to check it, plug 2 here. What happens if you plug 2 here? Okay, negative 6 plus 9 is 3. Okay, what is the slope of this line? Negative 3. Yes, that's how I know that already. So you can go back and verify all the information. Okay? Yes. I mean, even if you make a mistake in the algebra, you can check always before you leave the answers. Okay. Last one. It gives you a line y equal x over 2 plus 4, and you need to find the straight line that is perpendicular to this. Perpendicular means it creates 90 degree. 90 degree. The slope of this line is half. Can anybody tell me what is the slope of the perpendicular line? Negative 2. Because their product should be negative 1. Clear? Not the negative of exact number, negative of the reciprocal. This should be not negative half but negative 2. The idea is, if you have two, can I say this is M1 and M2? If you have two lines, they are perpendicular, their slope, the product of their slope become minus 1. That's the theory. Okay? Slope of the product equal to minus 1 if they are perpendicular. Yeah, this way. Always equal to negative 1. They are always negative 1. If I give you 1 over 3, this is negative 3. If I give you negative 4, this is positive 1 over 4.
Okay.
Look at this. This is positive slope, right? To get the perpendicular line, this should be negative always. You see, it should incline this direction. It's always negative. It's very clear. If I give you negative slope, the perpendicular slope is positive.
Yeah.
Clear?
So you
Plus, minus is clear. Yes.
So you just make the slope the negative or positive version of whatever it is.
Right.
Oh, okay.
And make it flip.
Oh,
You
okay.
have to- at the same time, you have to flip. Like
Yeah.
1 over 2 become 2.
Okay.
Flip and change the sign. Okay? Yeah. This is maybe you can write down it in your formula sheet. Right, I know the slope and it's given another point as well. So this is the point. It also goes through 1 comma negative 2. The question asks, find the equation of the line that contains this point. That means this line that contains the point and also perpendicular to the line given here. So I know the point and slope now. I can write my formula. Y minus y1 slope, again the same formula, okay? X minus 1. I subtract my x, I subtract my negative 2. Okay? Subtract negative 2, okay? It's not just 2 here. So it's become plus, see? Because I subtract the negative value. Negative 2x plus 2. You can see here plus 2 cancel out. So my answer is negative 2x. This is the straight line that goes through 1 comma negative 2. At the same time, it's perpendicular to the equation given here. do you believe this is correct? Plug 1. If you plug 1, you know I can get minus 2. Okay? Right, so first question, good. Number 2, the composition function. You apply composition function idea. Okay. So remember, in the test, you know how I change the question, right? I might change the number for point here, maybe I change the equation. That's something I can do. Because the only question I can ask you from, give you 2 points and ask you the straight line, or give you some parallel lines, the concept of parallel line, or perpendicular. That's all you have. Okay. Right. Number 2, composition function. How to combine function? 2 functions together. Right. So number 2. So 2 functions are given. Fx, x plus 2, and gx. This is a quadratic one, and the first one is linear. Just linear and quadratic. And the first question asks this one, f of gx. It's a new function. If I give you 2 functions, you can add, subtract, divide, and multiply. Those are the only 4 operations you used, maybe most common operations. This is new one actually. This is like one single function doing what the both functions are doing. Okay, so it's like so I can explain it like this for you. Okay, so think about this one. You first apply g to your x. This is your x. Like it's like you send a signal or whatever. You know, you learn these things in computer science or any engineering class you are taking. Sometimes bio classes also you use. If the temperature depends on certain properties, you have to first find that variable and plug it to temperature to find the temperature. Okay. So for an example here, if you plug x to your function g, you get gx, and you send gx to function f, and you get f of gx. You can write this one, f, you plug gx, the output of g, as an input of f. Okay, so let me write it like this. So it's like kind of 2 operations. First the function g apply and then f apply. You read this way, okay? G and then f. So let me start with some number to explain you nicely, okay? So let me start with 2. What happens if you plug to g? 2 to g. Anybody? What is, I'm asking what is g of 2? This is g, okay? G of 2 is what? The output if you plug 2 for g, you get 6, agree? 6. And you send 6 to f, and you get 8, agree? That's your answer. So I use 2 functions to do that. Now I have single function, I call f of gx. Let's see how to get it. You plug gx to f. This is read as f of gx. That means you apply, you send gx to f. Gx is my quadratic function, I plug it here. What is f doing? F is just add 2. Whatever you put, it's add 2 to that input. So if you plug 100, it gives you 102. If you plug 50, it gives you 52. If you plug this, it gives you that plus 2. Clear? It's like a rule or command. So look at this. If you plug 2 to my function, now what you will get? 4, 6, 8. See, I can go from here to here directly without calculating 6. Clear? This is my f of gx that I calculate here.
Wait, so are you saying that, like, I'm confused how we're getting like a regular numerical value, because can't you only get that if there's something, like it would have to be like f of g of 2?
Yes.
Oh,
If I ask f of g of 3 or f of g of 2, you just use that to get the answer.
okay, 'cause I was gonna say, I don't think you can solve when it's just the f of g. Like you can, it's just not like, there's still like a variable, that's what I meant.
The actual answer would be x squared plus x plus two.
Yes, that is
Okay.
my composition function. So your question here is like you're asking what if
I
I
got x squared plus 4. Because you plug in, right?
no you plus dx. Is
So
it
x-
2? This is x by the way.
So we can have the-
That's what's your mistake.
Oh my god.
Oh, yeah,
okay.
this is
I thought
x.
that was, I wrote that as 2.
Yeah, that's
I was
why
like,
I
wait,
understand
I
your
was like,
point.
why?
So if you it's
Right.
become 4. In
I'm
that
actually
case,
just blind, sorry.
No, you can ask questions. That's it's okay.
Oh, I did the wrong way. So you can
Yeah,
put f of g.
she put 2 here. That's why she thought it.
Yeah.
G value include x.
No.
I did it the other way, I read it as just go. It's a bug.
How about that? It's good.
It's just a bug.
So I'm going to do the part B, which is like a commute. You commute the operation. Commute by what I mean is previously you do the g function first and then f next. Okay. Now you have to do, when you read it, this is the first one. It's not like when we write it's like other way you read, like put the g first and then f first. Okay. Because you have to go through g and then f. This one, g of f. You first apply your function f to your variable x. What is f of x? I know it's x plus 2. Okay. Now, what is g doing? G is just square whatever you put. You see? If you put some input, it's to square it. So now I have to square my input. Add what? Anybody? X plus 2. So, because that's my input. It's like the square the input, add the same thing. That you can, I know sometimes you simplify that. You don't need to do that because we are not discussing algebra here. We are discussing, just get the composition. That's enough. Okay? If you want, you can really simplify and write it like a nice quadratic function. I'll give you, if anybody interested, it is like x to the power 2. This is 4x plus x is 5x. And 4 times 2 is 6. This is really the simplification of that. Okay? Right. And I can ask after that, like previously I asked you f of g2. Here in this practice problem I asked f of g3 actually. Sometimes you can say, okay, I'm going to use this. I'm going to apply g and I'm going to apply f. You can do that if you want. It's a little long. But I know f of g x, so I just need to replace x with 3 here. Okay? So because it's very quickly I can get. I replaced x with 3. As a fun homework, you can start 3 here and check what happened. What is G3, and you think about what is f of G3. And you will definitely get the number we discussed over here. 14. Okay? 14. Yeah. What is G? G of f3? Not 3 over there. 3 to the power 2, 5 times 3 plus 6. 9, 20, 30, right? It's 30, it's nice, 30. 30 is the number. Everybody good? Everything is good, everybody? So what what I will do, I can change this to maybe square root. Think about that, what if I change it to square root? Okay? Maybe I give you a cube here. But the idea remains same. You don't want to worry about, I will have a square root or whatever. You do the same process to get the answer. Right, let me check. We have a few more minutes. Number 3. Number 3. Okay, this is like a basic question. Again, we discussed like you have 300 feet plot to enclosed. One of the side is the river. Okay? Yeah.
I'm sorry.
Yeah, you're almost. So this is 300 feet entire fence. Again, you can use this width to be x. This is what? 300 minus what? Anybody? Because entire fence, yeah, 300. So it should be 300 minus 2x. Because if you add this 2, it's 2x. And you have to subtract that 2x to get the entire 300. Okay? You can think it's like this plus this is 300. Okay? Is that clear how I get? Okay. The reason is I don't know how much I need to choose my width to get the maximum area. So I want to make my plot maximum. So the question asks, you have 300 feet of fencing to enclose a rectangle plot that borders on a river, so you don't need to worry about this side. If you do not fence the side along the river, find the length and width of the plot that will maximize the area. So I'm writing my area of this plot, okay? The width times length. You see now, I wrote down my area as a function of width. I will write it like this. See? Now you can change your x, like for an example, you can change to x 10 feet, 20 feet, 30 feet, 50 feet, and so on. And you can check the area, and at a certain width, certain x, you meet the maximum area. I don't know if that exactly what is this value. I'm going to find it. Okay. So if you think about the graph of this, it would look like this. Okay. This is how the graph looks like. You don't need to talk about negative area or negative width. So this is the width. Okay. Width. And this is the area. If you have width 0, you can see when x equals 0, there's no plot. So I can't draw any plot if my width is 0. If my width is 150, can you see that? If I plug 150, what happened here? 300. So that means if I have 150 here, there's no length. Because I use entire pens. 300, I have 300 pens. I use it as here, it's like a tool, like a lines. It not covered anything because I don't have any pens to cover my length, right? So that's my, the domain is like 0 to 150. Since it's quadratic, it's look like up and down. How do you know exactly it's a quadratic? Because of the power 2. And how do I know it's exactly going like a up and down? Because of the leading coefficient negative. Okay? Right. Now, anybody remember how do we get the vertex? This is the maximum point, right? Vertex, x coordinate of the vertex is what? Minus b over 2a. Okay, yeah, that's it. B is what? 300. 2a is what? Negative 2. It gives me 300 over 4, 75. Which means at 75, I get the maximum area. That's good. Right, so that means you have to create the plot 75, 75, and what is the length? 300 minus 2 times 75 is what? 150. So this is 150. So if you enclose the plot like 75, 150, 75, that area use 300 feet fence, and it gives you the maximum area. So you can find the maximum area if you want. A max, you can say maximum area is, A max is 75 times 150. It is there. 150, 75, you can multiply it. So 5, 7, 0, 5, 3, 10. 10. Yeah. It's 0, 5, 2, 11. Okay? It's a square feet. The maximum area you can enclose. Okay? Clear?
Yeah.
Right. Let's stop from here. Okay. If you use any other dimensions, like, can I quickly show that really quick, okay? 50-50, if you use 50-50, this will be 200, agree? Because now it's 300. If you use this type of enclosed, of course you use 300 feet, but what is the area? 10,000. Way, way lower than this. You mean this one or this one?
Oh, yeah, yeah.
It's 11,250. Okay. It gives that is your number. That's the area, maximum. If you like I here the 50, if you use 50, it's 10,000. That's what I show the picture. So I discussed 3 problems. Wednesday probably I will be go a little faster and finish like 4 or 5 questions, and Friday by Friday we can finish all the questions. Okay. I'll do a little edit and post the video as well for you to refer. Okay. All right. Is there anything I forget? Okay. Worksheets. If you complete the worksheet that I asked you to do like 3 questions in the verify 90. Yeah, you can write your name in both. If you need time, bring that on Wednesday, okay? Bring on Wednesday.
Thank you for the review.
All right, good luck.